Welcome students to the session. Today's session is about workability of concrete. As we know, workability is one of the property of the freshly mixed concrete. So workability basically depends upon the different factors. So what is workability of concrete? Workability is nothing but the concrete is how much workable in its fresh state. That means the total process when you are preparing one concrete paste from the mixing to the placing, that process is under workability. So workability is the property of the freshly mixed concrete by which we can mix the concrete and transport the concrete and compact and finish properly. The total process of the concrete from mixing to placing is under workability. Okay. Then next is your bleeding. What is bleeding? Bleeding is nothing but the separation of water from rest of the mix of the concrete is called bleeding. When there is improper water cement ratio and water percentage is high in some case of concrete mix, then the extra amount of water deposited over the concrete surface, that is called bleeding. That means the separation of the water from rest of the mix is called bleeding. Next is segregation. Segregation is also the separation of the any of the material. It can be water paste, it can be aggregate, any water, any ingredient of concrete separating out from rest of the mixture is called segregation. Bleeding is also one type of segregation, but segregation is not bleeding. Then different causes of segregation. How segregation occurs? One is improper mixed proportion. That means when we are adding, when we are preferring some water cement ratio, if the proportion water cement ratio and the proportion of the materials, that is cement, sand and aggregate, total proportion is if we are taking improper, then segregation occurs. That means the ratio cannot be properly maintained. Then segregation is also caused by dropping the concrete from a large height. When we are placing the concrete, in case of suppose we are casting one column or any type of structure, when we are putting the concrete over the mold, into the mold, we have to maintain some height. When we are taking the different height or we are going for the large height, then segregation occur. That means the coarse aggregate can be separating out from the rest of the mix. Next is segregation is also caused by the over compaction. When we are going for the compaction process, when we are compacting the concrete number of times and more time, then segregation occurs. That is also one part of the segregation. Then bad transport facility. When we are transporting from the mixing place to the placing, to the casting place of the concrete, if there is so many vibrations into the transport, then there is segregation occur. Next is how we can measure the workability of concrete. That means how we can define that this concrete is workable or not. Some tests are conducted there. One test is slump test, which is mostly widely used, mostly used because it is very useful in the field. It can be we can test the result in the field, direct field, by avoiding the laboratory test. That's why it is very simple test, so that it can be tested in the field. Second one is compacting factor test. It is more accurate than a slump test, but for this test we have to go to the laboratory. Then VB consistometer. VB consistometer test is also carried out for the workability test. Then flow table test also for workability. Calibre test is also we are conducting for the workability test. So for this session I will discuss about the slump test, because slump test is the most important test conducted for the workability test. Now you can see in the drawing there is a slump cone. This is the slump cone or slump test apparatus. Only this apparatus is used in the slump test. Here you can see SLAM test is the most commonly used method of measuring consistency of concrete, which can be employed either in laboratory or at site of work. It is not a suitable method for very wet concrete. That means when we are going for the SLAM test, we will maintain some water cement ratio. That means this is the SLAM cone that we are using. One rod is measuring rod is there and cone is there. One base plate is there. Then SLAM cone apparatus are the SLAM cone apparatus along with tamper or tamping rod, which have 16 mm diameter and 600 mm length. The tamping end of rod shall be rounded at the hemispherical tip, ruler, etc. These are the apparatus we are using for the SLAM test. Next procedure. When we are using SLAM cone, we have to take the concrete paste. We have to pour the total concrete cone into 4 layer, and every layer we have to give the 25 blows, and we have to tamping it by using tamping rod. The internal surface of the mold shall be thoroughly cleaned. It should be free from moisture. We have to pour the concrete one layer by one layer. In 4 layer we have to cover the total cone. Then we have to struck off extra amount of concrete over the surface of the cone. Then the total height of the SLAM cone, as you can see, height of the SLAM cone is 30 meter and base diameter is 20, top diameter is 10. That means the height of the SLAM is 30. After putting the concrete over, the height is before removing the SLAM cone, the height of the concrete is 30 centimeter, and putting 4 layer, each layer we have to give 25 blows and we have to tamp it or compact it. In 4 layer we have to cover the total concrete cone. After covering the cone, we have to vertically lift the concrete cone so that the height will be decreased. That means the total height before lifting the concrete cone is 30 centimeter. After lifting the vertical cone, it should settle down in some depth, in some height. So that difference in height after, before and after removal of the SLAM cone, that difference is called SLAM height. Now you can see here, the mold shall be placed on smooth, horizontal, rigid and non-adjoint surface such as a carefully labeled metal plate. The mold being firmly held in place while it is being filled. The mold shall be filled in 4 layers as we have already discussed, each approximately 1/4 of the height of the mold. Each layer shall be tampered with 25 strokes of the rounded end of the tamping rod. The strokes shall be distributed in uniform manner so that overall the uniform compaction should be there. After the compaction, the bottom layer shall be tamped. Okay. After the top layer has been rod, strike up surface of the concrete by means of screening and rolling motion of the tamping rod. Any mortar which may have leaked out between the mold and the base plate shall be cleaned away. The mold shall be removed from the concrete immediately after raising it slowly and carefully. Vertically we have to remove that mold or cone in the vertical direction. This allows the concrete to subside and the SLAM shall be measured. That means the difference in height before removing the SLAM cone, the height is 30 centimeter. After removing the SLAM cone, what will be the height? That difference in height we have to measure, and that height is called SLAM height or the value of SLAM or SLAM value, which is in terms of, we can take in mm or centimeter also. For different workability or for different compaction pattern or SLAM, very low workability, the SLAM should be 0 to 25 mm. From for low workability, it should be 25 to 50. If the water cement ratio, if the water amount is very high, in that case collapse, there should be collapse. Then if the water cement ratio is medium range, then it considered as a shear slump. If the concrete is very steep, then it is called true slump. This is the three result of the slump test we can see. According to the construction, in the road construction, in the building construction, different slumps are taken. That means different slump values are there, and we can consider shear as the ideal or true, but collapse thing we have to avoid. That means we have to prepare the concrete mix. So this is all about the slump test. Thank you.